The overall conviction among most analysts is that the hypothesis of how things came to be stays the fundamental explanation for the early seasons of the universe. This speculation joins the advancement of stars, planets, and so forth, life on those planets, including ourselves, not getting through. There's a really odd hypothesis named the Big Bang. It offers an illuminating examination concerning what could have occurred at first. The universe was thick in a short space, more unassuming than a pinhead, with particles thickly stunned. From this moment, a giant impact of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up the spreading out of cosmic history. However, headways in real data have set off developing anomalies with the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the greatest and most advanced space science observatory ever, specialists conjectured that its observations would confirm the hypothesis of the universe's origins. Unfortunately, after just a year in space, the telescope surprised specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's stunning limits have uncovered endless systems going as far back to a time so old that it challenges how we might interpret the universe's beginnings. This discovery has touched off an intense examination into what existed before the Big Bang. One key moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, suddenly tracked down a galaxy from just a short time after the Big Bang, making it the most distant system ever observed. NASA's discovery sent shock waves through established analysts, highlighting the incredible abilities of the James Webb Telescope. Its primary goal to change our perspective on the universe has just begun, promising to reveal astonishing insights into the earliest phases of the universe's existence. This period, barely examined previously, holds the key to understanding the progress of the first stars and structures. The telescope's discoveries have conflicted with initial hypotheses, uncovering systems with attributes exceeding past assumptions. This great flood of early systems has sparked a storm of scientific inquiry, challenging specialists to reconcile these discoveries with existing theories. As scientists grapple with these revelations, they face crucial questions about the very nature of the universe and the forces that shaped its evolution. Beyond the James Webb Telescope's advancements, which are consistent, it is located 1.5 million kilometers away from Earth, safeguarded from ordinary interference, and cooled to nearly absolute zero by its tennis court-sized sun shield. The telescope includes a massive segmented mirror and extraordinarily sensitive instruments designed to uncover details of the early universe previously hidden. This period, known as the Great Dawn, occurred around several hundred million years after the Big Bang, marking the point when the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense investigation, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the vast first light presents an extraordinary opportunity for cosmologists to test how they might interpret these complex elements. By exploring these ancient systems, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to crucial new discoveries. Initially, the telescope was supposed to observe only a few faint and small galaxies in its pilot studies. However, reality has far exceeded these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that challenged all forecasts. This shocking flood of early systems has set off a race among space specialists to establish new standard records for the earliest known galaxies, with new revelations emerging consistently, leaving mainstream researchers in wonder. Following the James Webb Telescope's revelations, specialists and observers have rushed to study the presence of these shockingly advanced early worlds. Some theorized that errors in the telescope's interpretation of massive observations could be responsible for these unexpected discoveries. That said, the consensus remains that these revelations represent a shift in how we could interpret the early universe and provide exciting glimpses into the potential for cosmic evolution. The new discoveries from the James Webb Space Telescope regarding galaxies have raised key questions about the nature of the universe and challenged the assumptions of standard cosmological models. While some researchers are investigating whether these observations can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more intricate and confusing than previously imagined. The actual question at stake is our basic understanding of how the universe we know emerged from primordial chaos. The early discoveries of the JWST could reshape our fundamental ideas of cosmic history, revealing insights not just on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFan, senior scientist for science and research at the European Space Agency, puts it, "You build these machines not to confirm theory but to break it. You simply have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, Weir and a small group began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to see in the infrared spectrum, allowing it to peer much deeper into the universe. This capability is critical for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its enormous, cold, star-like mirror, the JWST became the premier instrument for unlocking the secrets of cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field observation revealed countless galaxies in what was believed to be an empty patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much further into cosmic history. After 20 arduous years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early efforts like the Early Science Program and the General Observer Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far surpassed them. JWST observations have tested existing models of the early universe, uncovering galaxies that defy conventional cosmological assumptions. These surprising revelations emphasize the importance of pushing the boundaries of scientific inquiry and highlight the remarkable abilities of cutting-edge technologies like the James Webb Space Telescope. As specialists continue to explore JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists were eagerly awaiting the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, researchers chose to share their discoveries on preprint servers like AR14, a platform for research papers that haven't yet been peer-reviewed. This approach allowed for a new kind of peer review to occur through social media platforms like Twitter, where mainstream researchers could immediately discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of conversation was both extraordinary and overwhelming. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Monel, a JWST project researcher at STSCI, warned that while the quick sharing of results facilitates rapid dissemination and discussion, there is also a risk of overwhelming the process. The overall understanding among most scientists is that the hypothesis of how things came to be remains the fundamental explanation for the early seasons of the universe. This speculation integrates the development of stars, planets, and life on those planets, including ourselves. Despite its surprising name, the Big Bang offers a significant explanation for what could have occurred at the universe's beginnings. The universe was dense, packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive impact of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, changes in scientific data have led to growing inconsistencies with the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, scientists speculated that its observations would support the hypothesis of the universe's origin. Tragically, after only 1 year in space, the telescope shocked researchers with its ability to peer deeply into the universe's past. The James Webb Space Telescope's exceptional capabilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked serious investigation into what existed before the Big Bang. While the findings from the James Webb Space Telescope continue to challenge our understanding, they are opening new avenues for research and discovery. Many experts now believe that the answers to some of the universe's most profound questions may lie in these early observations, and that our current models may need to be adjusted or completely rethought. The existence of these distant ancient galaxies suggests that the universe may have evolved in ways that were previously unimaginable. It also raises fundamental questions about the very nature of time, space, and cosmic evolution. The implications of these revelations extend far beyond just the field of cosmology. They have the potential to reshape our understanding of physics, the laws governing the cosmos, and even the origins of life itself. As the James Webb Space Telescope continues to gather data, its discoveries could offer unprecedented insights into the first few moments of the universe, the formation of the earliest galaxies, and the physical processes that led to the emergence of stars and other cosmic structures. These insights could ultimately help answer long-standing questions about the origins of the universe and the forces that shaped its development, providing a more complete and accurate picture of our cosmic history. In the years to come, scientists will continue to study the data returned by the JWST, refining their models of the early universe and testing new theories about the fundamental forces and particles that shaped the cosmos. As the telescope reveals more about the universe's past, it is likely that we will come to understand more about the present and the future of our universe as well. The James Webb Space Telescope has already proven to be a transformative tool, and its discoveries will likely continue to surprise and inspire the scientific community for decades to come. The James Webb Space Telescope, JWST, has already proven itself as a transformative tool, but its work is far from complete. As new data continues to flow in, it is likely that scientists will discover even more about the universe's past, possibly unlocking secrets about its early evolution that had previously been out of reach. One of the most groundbreaking aspects of the JWST's mission is its ability to look deeper into the universe than ever before, essentially looking back in time. By capturing infrared light, the telescope can observe objects that are too distant or faint to be seen by previous observatories like Hubble. In addition to unveiling new galaxies, the JWST is helping scientists test existing cosmological models and push the boundaries of what we know about the universe's origins. The data it's collecting not only challenges old assumptions but also suggests that the cosmos may have developed in ways that are far more complex than we ever imagined. For instance, the telescope has revealed galaxies that appear to have formed much earlier than previously thought, potentially pushing back the timeline of cosmic history. These discoveries suggest that the universe may have been able to support galaxy formation earlier than expected, which could lead to revised models of the timeline of cosmic events. As these new galaxies are studied, scientists are beginning to refine their understanding of the processes that lead to the formation of galaxies, stars, and even life. The JWST has already revealed important clues about the chemical compositions of early galaxies, providing insights into how they evolved and how stars within them formed. These revelations are helping scientists develop a clearer picture of how the universe's first galaxies coalesced from the primordial fog of gas and dust. This process, called cosmic reionization, is one of the most significant periods in the history of the universe. It marks the point at which the first stars and galaxies began to emit light, clearing the fog of hydrogen gas that had previously filled the universe. One of the most exciting areas of exploration is the study of exoplanets. The JWST's advanced instruments are providing an unprecedented look at distant planets outside of our solar system. By studying the atmospheres of these exoplanets, scientists are learning more about their composition and potential habitability. This could ultimately help answer one of humanity's most profound questions. Are we alone in the universe? The ability to directly analyze the atmosphere of exoplanets opens new possibilities for identifying signs of life or conditions that might support it. Moreover, the data from the JWST is enabling scientists to investigate the fundamental forces of nature that shape the cosmos. The telescope's advanced technology allows it to observe distant cosmic objects, such as black holes and quasars, that were previously inaccessible to researchers. These observations provide valuable insights into the extreme environments around these objects and could help scientists better understand the laws of physics under extreme conditions. This could have implications not only for cosmology but for other areas of physics, including quantum mechanics and gravity. As the telescope continues to explore the universe, there is also a growing interest in how the discoveries made by the JWST could impact our understanding of dark matter and dark energy. These mysterious substances make up the majority of the universe's mass and energy, yet their properties remain elusive. By observing the behavior of galaxies and the structures that emerge in the early universe, the JWST could help scientists better understand how dark matter and dark energy influence the cosmos. This could be a critical step in solving one of the greatest mysteries in modern physics. In the coming years, the JWST will likely continue to challenge our preconceptions and push the frontiers of scientific knowledge. As more galaxies are discovered, more data is collected, and more hypotheses are tested, our understanding of the universe will become increasingly refined. The telescope's discoveries could have a profound impact on various fields of study, ranging from the origins of the universe to the potential for life elsewhere in the cosmos. The wealth of information it is generating will keep astronomers and physicists busy for years to come, and it will undoubtedly shape the course of scientific exploration for decades. Ultimately, the James Webb Space Telescope promises to be one of the most significant scientific instruments in human history, offering profound insights into the universe's most fundamental questions.